Okay, good morning. Welcome to
KidMath92.
KidMath92. So we actually have been distracted a little bit by your parabola question, which is a really cool question. And we actually have already gone through in our Art of Problem Solving book the section on the trivial inequality, which just says if x is real, x squared is greater than or equal to 0. Okay, now it seems like a pretty simple statement, right?
Yeah, and it is true.
When is it greater than 0?
When x is not equal to 0. So
Okay. When x is not equal to 0, x squared is always greater than 0.
Yeah.
And when is it equal to 0?
when x equals 0.
When x equals 0. Okay, awesome. So as simple as a statement that this is, there's a lot of surprising things you can prove with this. And one of the things they said, let's prove this, if x is greater than 0, x plus 1 over x is greater than or equal to 0, which is true, obviously, but 2. Okay? So we're now, instead of just x being real, we're going to say x is greater than 0, and we can't have it equal to 0 because of the 1 over x.
Yeah.
And this certainly would not be true if x is less than 0. Why not?
Because you have negative minus a negative. You have negative plus a negative, which is still negative.
Yeah. So there must be some other inequality that's true when x is less than 0. In fact, could you guess what it is when x is less than 0?
The sign goes the other way.
Yeah, there you go. Okay, so how do you think we should try to deal with this?
We can try a few numbers. Let's say x equals 1. We get 1 plus 1. This is greater than or equal to 2.
Yeah, okay, so 1, it seems to work.
Well, x equals 2. You get 2 plus 1/2, which is greater than or equal to 2.
All right.
So, but when x gets bigger than 2 and x gets 3, you get 3 plus 1/3. But you're already starting bigger than 2.
Right.
So, it's going to go, if x is greater than 2, this is true.
Okay, so it seems to be true. You've tried a lot of things, and it seems to be sort of obviously true when x is bigger than 2.
Yeah, but when x is 1, it's still true.
It's still true, okay. So how do you think you want to prove this in general, rather than just trying all the numbers? Because trying every single real number...
It's going to take a long time.
Yeah, it's going to fill up with a bunch of sheets of paper. Probably have to go through a lot of markers.
Yeah.
Yeah. What do you think here?
Well, we know it works when x is greater than 2.
Yeah, that's true.
But when we have x equals 1/2, it's the same as when x equals 2, but the equation's flipped.
Yep, that's absolutely right. So let's move away from numbers now and try to work on the algebra. Okay?
How can we prove this in general?
How can we prove this in general? What do you think? Give me some ideas.
Well, we could say x plus 1 over x equals 2 to make it a little easier.
Okay.
Maybe not.
All right, maybe not. Okay, remember we're starting with our trivial inequality that says any number squared is greater than or equal to 0. That's the sort of base of this section. Does this look like that?
No.
No, it does not.
How can we manipulate it so it does sort of look like that?
Yeah. Okay.
Maybe we could multiply by 1 over x. We'll multiply by x.
Okay, multiply everything by x. Let me write over here. Okay. So what do I get when we multiply by x?
X squared plus 1 is greater than or equal to 2x.
Greater than or equal to 2x. And the inequality doesn't change because we're multiplying by a positive number. Okay?
We multiply by negative.
Because x is greater than 0. So we can always multiply by a positive number. So here you multiplied by x. Okay? What now?
Well, we want to get something that looks sort of like this.
Yeah, something.
So maybe subtract 1. Oh wait, no, you can't. You can't do that.
You can't subtract 1?
Well, subtracting 1 from both sides,
Alright.
you get x squared is greater than or equal to 2x minus 1.
Yeah. Definitely doesn't look like something squared is greater than 0.
It would be nice if we could eliminate the 2x.
Okay, how would you do that? It would be nice if we could do that. What would you do?
But dividing by 2x.
Yeah, dividing by 2x doesn't work, and even if you did, that would get you something greater than or equal to 1. Okay, we want something greater than or equal to 0.
If we subtracted 2x from both sides,
Okay, what would you get if you subtracted 2x from both
you
sides?
get x squared minus 2x plus 1 is greater than or equal to 0.
Okay.
At least we have the 0 now.
Yeah, well, now we have something is greater than 0.
And we have a quadratic.
We have a quadratic.
Hmm.
Alright, what now?
Well, this is x minus 1 squared.
This is x minus 1 squared. Is that going to be true? Is x minus 1 squared always going to be greater than or equal to 0?
Yes.
Why?
Because when x is negative, you have a negative squared, and that's positive.
Okay.
And when x is 0, you have 0 squared, which is 0.
No, 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 no.
Yeah. When x is 0, you have a negative.
Yeah,
When x is 1, you have 0 squared.
right.
And when x is bigger than 1, you're going to have a positive squared.
Okay, so let's say it a different way. This is always going to be some real number, right?
Yeah.
And any real number squared is
Bigger than or equal to 0.
bigger than or equal to 0 by what? By what rule is any real number squared greater than or equal to 0?
Well, because negative times negative is positive. And
By our
trivial inequality.
trivial inequality. Any real number squared is greater than 0. Okay? So, we took a simple statement, x squared is greater than 0, and we produced a statement that was much more complicated. X plus 1 over x is greater than or equal to 2.
And we found out that it equals this. Well, almost equals.
We found out we could manipulate this equation into this form just by our rules of algebra. We multiplied by x, we subtracted 2x from both sides, and we factored. And that produced a really interesting statement that was true because of this very simple statement that any real number squared is greater than 0. Okay?
Yeah.
So this statement, any real number squared is greater than 0, turns out to be able to prove really interesting facts. Pretty neat, right?
Yeah.
All right, good job, hon. Good job. That was a struggle. But that's getting into some really, really interesting math.